Now that we know how we're setting up our alarm constants and the data that we are indexing with those constants, it's now time to have a look at how we actually raise an alarm. So I have a global alarm manager here, which I've already developed. I'm just going to drop one on here and give it a test instance, and we'll have a look at how this all comes together. So we've seen these before in previous lessons where we looked through some of the asset managers, but we didn't go into any great detail on why they're set up this way, what we can do with them, and how they work inside. So the global alarm manager is already a typed object. I've already tested this and put it into the library management system. What it consists of is a condition input. This is the bit that's going to trigger the alarm. We have an inhibit input, which says even if the condition is true, you're not allowed to raise the alarm if the inhibit is active. That's useful for segregating out things that would stop an alarm from being raised, such as a sequence isn't active, and not having to include that in the condition line. So you can end up with something like this, where you have 3 requirements to raise an alarm. All of those need to be active, but you might end up with lots of different reasons why you are inhibiting the alarm. And what we don't want is to have to put all of this stuff on this line as well. Especially if you're in something like SCL, it becomes very messy to deal with all those conditions. So trying to segregate those out just makes a lot of sense from a fault finding and a diagnostics point of view later. Here is where we would put our index. So a good little tip here, I might have shown you this before, but it's just to come to A1 alarms, and in the details view, you'll see all of your constants. And you can search or order by name, because you're likely going to know what asset you want to raise an alarm by or what you've called your alarm. And then just say we wanted to raise this high alarm for QI3, you can then just drag it in. And that would then put A14 on there. The index is 14. And then in here, this would be alarms, alarm data, sorry. And then the group is A1. And then this would be alarm data and then management. And you might say, well, you could just put in alarm data and have everything in one big UDT. And you could, but you lose the flexibility then of being able to set the size of the data block yourself. So if both of these were in one big UDT and we just had one interface going into our block, then it would always be management and one group. Otherwise, you'd have to keep updating it every time. And that's something else that you need to consider when following this approach and using UDTs. You need to make it so you're not having to update your standard library all the time. Because if you're having to change things all the time, then it's either not flexible enough or it probably shouldn't be standardized. So this is one of those things. So you might decide that you want 4 groups because you often use up to 4 groups, and that would be acceptable. You could standardize that, and you'd have to take the hit on the wasted groups if you're not using them. But it makes a lot more sense in something like this to just have a data block and then pick the group that you're raising an alarm in, because it's unlikely that you're going to have multiple alarms with different indexes in different groups that need to be raised at the same time off the same condition. So yeah, separating that stuff out makes a lot of sense. The outputs that we have are alarm active and alarm status. And then if we go in and have a look at the actual sort of how this is working on the inside, it's a little bit difficult to immediately see, but it will make sense as we go through it. So it's written in SCL for no other reason other than if I want to use this in a different development platform, such as CodeSys or something like that, I can lift it out pretty easily, copy and paste it out, because this is the approach that I always use. So that's why it's written in SCL. But we're set into different areas. So new alarm, accept alarm, reset alarm, and then the statuses. So basically what we have is if a condition is active, I might just pull up the interface as well, because it might make this a little bit easier to sort of understand as we talk about it. So if the condition is active, this one here, and we aren't inhibited, so not inhibit, so this isn't true here, then we can index our alarm group using the index input, so A14 in this case. It will index the alarm group, so alarm data A1, and set the variable to true. And in doing that, that will raise an alarm on our SCADA. And then if the accept button is pressed in our alarm management, so alarm management here, so from the HMI or SCADA, if somebody presses the accept button and the alarm is active, then we set the alarm group accepted to true. And that is the trigger event on the HMI or SCADA to accept the alarm and say the alarm's been accepted. And sometimes those HMIs or SCADA systems, the accept button is built into some sort of control and it does it itself. Other times you can have your own accept button that accepts global alarms, sort of all of the alarms. But in any case, you'll always be writing to a variable for acceptance of that alarm to say or tell the PLC that it's been accepted. And then down here for the reset alarm, it's a little bit more involved because we are saying as long as the condition is not active, because what we don't want to do is reset the alarm and immediately have it come back in on the next scan. So the condition here must be false, so we know we won't re-raise. And as long as the alarm group accepted, so as long as this stage up here has happened and we've accepted the alarm, because if an operator hasn't accepted an alarm, we don't want to reset it. We want the operator to be able to choose which alarms they want to accept and reset rather than just blanket accepting and resetting everything. So we do a check to make sure that the alarm has been accepted by somebody. And then if the alarm management reset has been pressed, which is in this alarm data management here, then what we do is set the accepted to false and set the alarm to false. And that clears the alarm off of the HMI or SCADA system. We did touch on this in the last lesson. You could have additional steps. You could have a mute or you could have a clear to clear accepted and reset alarms off of the system. But just to keep things nice and simple for this, we just have the two states, the most common ones, which is accept and alarm. So that manages the entire raise, accept, reset procedure. And then down here, we have some statuses which come in handy if you want to show stuff on SCADA about the current state of an asset. So, for example, you might say if a alarm is new in and hasn't been accepted, you might want to flash the asset red. If the alarm has been accepted but is still active, you might want to show the asset as solid red. If the alarm has been, well, I've got them all here. So yeah, if the condition is active and the alarm is unacknowledged, then we could be red. If the condition is no longer active and the alarm is unacknowledged, then we could have it as pink. If the condition is active, but there's no reset available, the alarm acknowledged but is still active. So this is the condition is active, but the alarm has been acknowledged, but it's still active. So we've accepted it, but the conditions come back, so you can't reset it. Then you have it display as a different color, or it could be flashing again when it's pink or something like that. And then the last one is the condition's no longer active. The alarm has been acknowledged. It's now free to be reset. And obviously you have condition 0, which is there's no alarm, or there's no reason why we'd be saying anything other than this system is healthy or this alarm is healthy. And bundling those sorts of statuses into our assets via the global alarm manager, it makes a big difference to how you can interact with your stuff on your HMI and SCADA. Now, notice that we don't retain the status as part of the alarm data. And there is a reason for that. The reason is when we are working inside an asset, when we're working inside an asset, such as a pump or a valve or an instrument, we will probably have indication on the HMI or the SCADA that asset has a fault. Whereas when we are working with a sequence or some sort of control element, or we are just simply creating an interlock that needs to be accepted and reset on SCADA or the HMI, we probably won't need to have all of these different colors and things like that. It will just be a text that comes up in an alarm banner somewhere that says you need to accept and reset this before you can continue. So I didn't want to include the alarm status as part of the alarm data because it's an integer, I believe. Just hover over that and check. Yeah, it's an integer, and they take up a lot of room. Having an array of 256 integers when you won't be using all of them seems a bit wasteful. It's much more wasteful than having 256 booleans and not using them all. So the alarm status is not tied to the alarm data. And if we just look at where else this is used, so if we look at the quarter turn valve manager, you should see that I'm writing out on the alarm. Sorry, if I just come up to the alarm managers here and we look at like fail to open, we should see that on the alarm status, I'm writing out to the asset data alarms statuses fail to open, and that can be used to drive the mimic or the page on SCADA or a HMI to demonstrate to an operator that there is something wrong with this valve, it's failed to open. And not only that, the current state of that alarm, whether it's been accepted, whether it's been it's come in and then the conditions come in again after it's been accepted and things like that. And if we wanted to, you could also use the alarm status to cause some programmatic events after the global alarm manager. So hopefully that gives an insight into how we manage a singular alarm, but as part of a repeatable system, and it all hinges around one array and one function block. And that will be used in every single asset control system. Anything that is to do with interacting with alarms will have to go through one of these global alarm managers.